We're still in our unit on circles. And in the last lesson, we were talking about inscribed angles and inscribed polygons, meaning they're inside the circle. Well, today we're venturing outside the circle, and we're talking about tangents and how they interact with the circle. So here we go. A tangent to a circle intersects the circle in exactly one point called, not surprisingly, the point of tangency. So RS and TS are both tangent to circle P. Now a line is tangent to a circle if and only if it's perpendicular to a radius at a point of tangency. So if RP is a radius and RS is a tangent, we know that those lines are perpendicular. If two segments from the same exterior point are tangent to a circle, then they are congruent. So RS and TS are both coming from point S and are tangent to the circle P, then those are congruent. Now, AB is tangent to circle C, so we need to find X. Well, if AB is tangent to circle C, then that means AB is perpendicular to the radius BC, and we have ourselves a right triangle. So to find X, we can use the Pythagorean theorem. X squared plus 8 squared equals 17 squared. Now, where did that 17 squared come from? Well, you can see AD is 9. DC, well, it doesn't have a measurement, but I know it's a radius, and the radius measurement is 8. So AC, the hypotenuse, is 17. So, like I said, we can plug this into the Pythagorean theorem and solve for X. So we know that X is 15. We're going to find X again. And it says that assume the segments that appear to be tangent are tangent. Well, okay, TS and US appear to be tangent. And since they both meet at the same point S outside the circle, then those two segments, those two tangents, are congruent. So 7x minus 3 equals 5x plus 1. And again, we can solve for X. When a polygon is circumscribed about a circle, that means that all of the sides of the polygon are tangent to the circle. And that means that all of the rules of tangents apply to each of the sides of the polygon. Let me show you how this works. ABC is circumscribed about circle O. So we're going to find the perimeter of ABC. So let's just see first what we know. We know that if two segments from the same exterior point are tangent to a circle, then they're congruent. So if BE equals 6, that means BD also equals 6. If AF equals 12, well, then AD also equals 12. And if FC is 8, then EC is also 8. And we can add all of those numbers together to find the perimeter of ABC, which is 52. Let's try one that's a little bit more complicated. Still finding X, and then finding the perimeter. Let's start with 18 here, and we know that 18 equals 3x. Okay, so 3x equals 18, that means that x equals 6. So we found x. Now we're going to work on the perimeter. So TB is 12, so, well, BV is also 12. Now, what do we do here? We need to find UD so that we can find DV. Well, to find UD, we can just take 52, the whole length of that side, minus 18, and we get 34. So if UD is 34, that means that DV is also 34. And again, we just add up the sides, and we get a perimeter of 128. So we've gone from inside the circle to outside the circle. But no matter where you are, inside or outside of a circle, there's all kinds of cool relationships to learn about. Thanks for being here.